Hello, dear CAT aspirants. I hope you all are doing a rock solid preparation for your upcoming CAT exam. So, today we bring to you another video on number series that is a topic in your logical reasoning section. In the previous video, I have already mentioned that this topic does not keep a lot of importance from CAT point of view. But yes, if you talk about other MBA entrance exams, this topic does come. CAT also may ask it because it is mentioned in the official syllabus, but it is not mandatory that every year a question may come from this. In the previous video, we had discussed what should be the correct approach, and the gist of that was that you need to learn the squares of numbers from 1 to 30. Better would be from 1 to 40 and cubes of numbers from 1 to 30. So do it anyway, paste it on your wall, notebook, make it your phone or laptop wallpaper, but do it at any cost. These were the squares from 1 to 30 in front of you. I hope you all have noted it down in your notebook or wherever you are making your notes, and you have started revising them on the daily basis after your breakfast, lunch, and dinner, just like the medicine, so that you can see the effect on the final day. And these are the cubes from 1 to 30. Similarly, you have to learn this. Also, I told you learning the prime numbers from 1 to 100 will also help you a lot to get the patterns clicked in your mind immediately when you see some sort of series. Okay, so in today's video, we are going to practice questions. So in the previous video, we have talked about types of series and we discussed various possibilities that what kind of series could be there in front of you. But again, the question on the judgment day may or may not be belonging to one category. It may be an interdisciplinary question, maybe asking, it may be a series which is a combination of various types of series. So the motive in the previous video was to introduce you with the basic type of series that are present, but then it is all upon your practice. This topic is all upon your practice. If you feel bored after doing long practices of difficult chapters of LR, Quant, and DI, I would suggest that you can do number series, you can practice number series to refresh your mind, and also side by side, you are preparing for your CAT exam. Okay, so let's move to the question. So this is the first question. 1 comma 2 comma 10 comma 37. So what is the very first approach? When we look at numbers, we see that 1 and 37 are, there's not such a huge difference, so it may be a kind of different series. That was the first one. So plus 1 plus 8 plus 27, and I hope you must have guessed the pattern by now. This is 1 cube, this is 2 cube, and this is 3 cube. So next number would be addition of 4 cube, that is 64. So 37 plus 64 will give you 101. So this was a simple question to start with, to fuel you up for the upcoming questions which are of an advanced level as well. So such questions you should be able to do verbally. Please try that you do not pick up a pen or a paper for such kind of questions. It is just like that you should look at the pattern and you should be quickly able to predict the answer, and that will only come by practice. That will only come if you are familiar with numbers like these. Also, before we move towards the rigorous solving, again, very important instruction: please open your on-screen calculator side by side. Do not use the mobile calculator. I say this in every video, and I will be repeating it in final videos as well, because this is so important. This is a game changer. So you have to practice on this very calculator only. Also, please keep a notebook with you. Solve with me, pause, look at the question, pause it, and try to answer it on your own first, and then come back for the solution. So this is the correct approach to solve the questions of number series. Okay, so now let's move to the next question. Ideally, you should pause this and not take more than 1 minute to solve this question on your on-screen calculator as well. So here is the question presented in front of you. And now those who have watched my previous video, they must be aware of that whenever you see a decimal number and whenever you see repeated numbers, generally, when I say the word generally, I'm trying to say 90% of the time, the concept of fraction multiple goes well. Concept of fraction multiplication, there are high chances that this concept may be used whenever you see number in decimal or you see repeated numbers. See, for repeated numbers, there is a chance that it may be Fibonacci also. It may be Fibonacci sequence as well. So you can check for both. Okay, so now let's check. Let's go with the first concept that there are high chances that it may be present because there is a decimal number. So let's check. So while going from 12 to 6, so how do you go from 12 to 6? I hope you all are aware that 12 into half will make it 6. Now from 6 to 6, so 6 into 1 will be 6. 6 to 9. So 6 into 3 by 2 will make it 9. Next is 9 to 18. So 9 into 2 will make it 18. I hope by now you must have recognized the pattern half, 1, 3 by 2, 2. So next number according to us should be 18 into 5 by 2. But when you solve this, it comes out to be 45. So that is it. We have got the next number as well. So after this, the next number should be multiplied by 3. I hope you are getting it. It is multiplied by half, then 1, then 1 and a half, then 2, then 2 and a half, and now 3. So 90 multiplied by 3 will give you 135. And also you can check the correctness. Next number will be nothing but 135 multiplied with 7 by 2. So when you do that, you get 472.5. So our answer is correct. So you must have seen that generally it takes 4 numbers to identify the pattern in a full-fledged form. If you observe a pattern for 4 numbers, you can surely say that this pattern will be followed. For less than 4 numbers, there may be a chances that pattern may differ with the upcoming numbers. But yes, when you see a pattern for 4 consecutive times, you can conclude surely that this is the pattern. Okay, so see, I told you, whenever you see decimal number, please at very first try to apply the concept of fraction multiplication, and 90 to 95% of the times you will get your answer. Okay, let's move to the next question. Again, pause it. Should not take more than 1 minute. Okay, so question says 1, 3, 2, 5, 3, 7, 4, 9, 5, 11, 6. So you can see the series is not continuously increasing or neither continuously decreasing. Right, like here it is increasing, then decreasing, then increasing, then decreasing, increasing, decreasing. So there may be some pattern for such series. Let me try to check Fibonacci first. Like over here, if you check for the first two numbers, 1 plus 3 will give you 4. So that's not it. But if you look it in the other way, 3 minus 1 will give you 2. Let's try checking with this pattern further. Then 3 plus 2 will give you 5. Then 5 minus 2 is giving you 3. I hope you are getting 3 minus 1 was giving 2. 3 plus 2 is giving 5. Now 5 minus 2 is giving 3. Similar way, 5 plus 3 should give 8, but it is 7. It means that, our first interference was not correct. So now let's try looking it from the other angle. Let's try finding the difference and addition factor in the consecutive. So the very first thing we tried it because it looked a very simple series. So I thought of, applying Fibonacci first, but it didn't work. So let's check further. Now, while going from 1 to 3, it is plus 2. 3 to 2, it is minus 1. 2 to 5 is plus 3. 5 to 3 is minus 2. 3 to 7 is plus 4. 7 to 4 is minus 3. So you can see the pattern now. Alternate plus minus, plus going in 2, 3, 4, minus going in minus 1, minus 2, minus 3. So over here, this should be 4 plus 5 is 9. 9 minus 4 is 5. So 5 plus 6 is 11. 6 minus 5 is 11. So what should be the next number? Or this was minus. So now it's the turn of plus. So plus 7. So next number is nothing but plus 7. So 6 plus 7 will give you 13. So that is the answer. So you can see how easy the number was. And you know, how did I recognize? I saw that the series is not something very huge. There is not so huge difference between the consecutive numbers or the first and the last number. So it may be something belonging to addition or subtraction category, but then you saw that this series was a combination of the both. So alternatively, the pattern was changing, plus then minus, plus then minus. So this kind of mixture is also very well possible. Okay, so this question should not take more than 1 minute, or I would say if you have good analytical skill, it should not take more than 30 seconds. Okay, let's go to the next question. 5, 12, 23, 50, 141. So in such kind of series, you know, the very first approach, again, the layman approach is that we will try to find the addition factor first. So 5 plus 12. So, sorry, 5 to go to 12, I'll have to add 7 to it. From 12 to 23, I'll have to add 11 to it. From 23 to 50, I'll have to add 27 to it. And then from 50 to 141, I will have to add 91 to this. I hope you all are doing these things on your calculator. Now I cannot see any pattern in this. I cannot see any pattern in this. So now next thing is that we'll try doing it by multiplication. But dear aspirants, if you try observing this pattern further, there may be a pattern in the pattern. Like if this is something that you are seeing that this is something vague, there's no pattern, this is, you know, disordered, random. But now if I take out the difference of this particular series, so over here, you know, 4 plus 4, then over here you will have plus 16. Then from 27 to 91, how do you arrive? By adding 64. And now you can see the pattern. I hope now you are understanding that how you can see the pattern. First number was 4 into 1. Second was 4 into 4. Next is 4 into 16. So next number, according to you, what should that be? You can see that every time it is multiplied by 4. 4, then 4 fours are 16, then 16 fours are is 64. So next number will be nothing but 64 into 4. So that is 256. So over here, the next number will be made by adding 256 to 91. So 256 to 91, when you add 256 to 91, you get 7. Then 4, 347. It means next number will be addition of 347. So when you add 347 to 141, you get 488. So you can see this is one of the favorites of the examiners, because generally what we do is we will stop at this step. You know, when we see that, okay, there's no pattern, let me try something else. We stop at this step, and here is where the examiner will try to fool you up with other tricks. So sometimes it is better to check, if you're not getting anything, it is better to check for the pattern twice at least. Like over here, I did not see any pattern, but then by checking but then by considering this as a series as well, I got a pattern. I got a pattern. So this may happen number of times. So rather than stopping at this step, I would suggest that please go one step further. You may get your answer. There are chances that you may get your answer. Okay, let's go to the next question, number 5th. So 1, 1, 5, 49, 11, 169, 19. Now, when you look at this series, it should quickly strike to your mind that I can see some familiar number. 49, you know, is 7 square. 169, you know, is 13 square. Rest I cannot see anything, but then I can also see a repeated number. So should I try applying Fibonacci over here, or should I try applying you know, fraction multiplication? So you can try doing these concepts. But the other concept which can be present in repeated numbers is, whenever you see repeated numbers, I told you there are chances that it may be fraction multiplication. So the first approach should be fraction multiplication. It is better there may be a decimal, you try for this. If there is not, then you shift to the next one, that is Fibonacci sequence. So it may be Fibonacci. Or the third approach is that it may be alternate series. Alternate, when I mean to say that there may be two series present in a single series. Like if I try to break this alternatively, so there will be two series, 1 comma 5 comma 11 comma 19, and the other series will be 1 comma 49 comma 169. And now I hope you can recognize the pattern. If you look at the first series, this will be plus 4, this is plus 6, this is plus 8. So you can see even numbers are being added. And now if you look at this, this is 1 square, this is 7 square, this is 13 square. Now you will wonder, now I can see these are squares, but there's no a particular pattern. But if you look carefully, there is a pattern. 7 minus 1 will give you 6. So there's an addition of 6 to the next square number. So first one was 1 square. So next is 1 plus 6, that is 7 square. If you look at this 13, 13 is again 7 plus 6. So this is again 13 square. So the next number will be nothing but 13 plus 6 square, that is 19 square. And we all know 19 square is 361. So over here, the next number that will come is 361. So this kind of pattern is also very common, where you see repeated numbers. There may be two series present in a single series. So please do try this as well. Okay, let's move to the next question. So this is a type of new type of question which you can get. In this, you don't have to find the next number in the sequence. Rather, there is one wrong number in the sequence. You have to find this number. And what should be your approach for this? First, you try doing it with the difference always, and then you go with the multiplication thing, because there are high chances in this that it may be something belonging to multiplication. And when you check for multiplication in wrong number, do not check for exact multiple. It is better you check in terms of approximation. So in the coming video also, we will be doing 2 to 3 questions like this. So we'll discuss along with the question only. So now you pause it, give yourself a time of 1 minute and try to solve it, and then come back for the solution. So over here you can see 28, 84, 112, 196, and so on so forth. Now the very first approach is that, okay, I'll try to find the multiplication, because first and the last number are very different from one another. But then when you will try multiplication, you will find out that it was of no use over here, it was of no use over here. But then I told you that before doing anything, please try Fibonacci once. Please try Fibonacci once. So let's try Fibonacci over here. And yes, presto, it works. 28 plus 84 will give you 112, right? 84 plus 112 will give you 196. Then 112 plus 196 will give you 308. Then 196 plus 308 will give you 504. 308 plus 504 will give you, so this should be 512, sorry, it should be 812, but over here you can see it is 872. So this number is wrong in the series. The number should be 812, and it is which kind of series? Fibonacci series. So you can see how easy it was. But looking at the difference between the first and the last term, we all will start doing a lot of rigorous multiplication and start thinking. So I told you that, if your gut feeling says that let me try something first, right? Sometimes things works on intuition as well. So please check for Fibonacci at the very first chance. There are high chances that the answer may be hidden in this kind of sequence. Okay, let's move to the next question. 9, 31, 73, 141. So this series is a good one. I would suggest please pause it. Take around 1.5 minutes to solve this. 1 minute 30 seconds to solve it, and then come back for the solution. Now, if you remember in the previous video, I have taught you some special series where I told you that you have to learn these series because such patterns are, very difficult to identify during the exam when you have all that pressure on your mind. So if you remember, they were of the form n cube plus n cube minus n cube plus n square, n cube minus n square, and I suggested that please learn these series for, n is equal to 0 to n is equal to 6. So this is also a form of this series, but it is a really a modified series, a little bit advanced level of what we had discussed. So if you look at 9, you can write down 9 as 2 cube plus 1 cube. I hope there's no doubt in it. So that is 8 plus 1. You can write down 31 as 27 plus 4. That is, sorry, 2. Now 27 plus 4 will be 3 cube plus 2 square. So rather than writing 1 cube over here, I can write down 1 square so that there can be a pattern. 73 can be written as 64 plus 9. So that is nothing but 4 cube plus 3 square. So I hope by now you must have identified the pattern. Let's check for 141 also. So 141 can be written as 125 plus 16. That is 5 cube plus 4 square. So you can see this is a series of the form n cube plus n minus 1 square. So that is a modified version of the, this. Something similar to this, not this, modified version of this. Something similar to this, but then over here n is not the same. First number is n, so the second number is taken as n minus 1. So the next number over here should be, according to this pattern, it should be 6 cube plus 5 square. So 6 cube is 216 and 5 square is 25. So when you add this, you get 241. That is your answer. So the next number over here in the sequence is 241. So now these series look, very easy when you look at them at once. But then, trying all the, mathematics of the world, it becomes difficult to arrive at the answer, because I told you last time the general psychology while solving the questions of series is that we think that there must be a relation between two numbers, and we try to figure out the relation by doing the addition, subtraction, multiplication, division and stuff. But in such kind of series there is a pattern, but the pattern is on the individual members of the series. There's no pattern between the two numbers. There's no addition factor, no common difference factor, no common multiplication factor. But then if you look at the numbers individually, there is a single pattern that is being followed. So that is why I told you that these special series can be present if the examiner wants to, make you waste your time or wants to make the paper difficult. So this kind of question, is something that would be the favorite one. So please learn these type of series so that this can also click into your mind. This can also click into your mind after doing all the stuff. Okay, let's come to the next question, number 8. So over here, let's first try to find the difference. This should not take more than 1 minute. Again, if you are pausing and trying it, should not take more than 1 minute. So to arrive at from 120 to 245, you will have to add 125 to it. While arriving from 245 to 461, you will have to add 216. Yes, now I can see some familiar numbers. If you know this is 5 cube, this is 6 cube. Let's check for the next one. To arrive from 461 to 804, you need to add 343. So we got a pattern. Kudos, we got a pattern. 5 cube, 6 cube, 7 cube. So next one should be 8 cube. 8 cube is 512. So again, this is, verifying. So the next number in the sequence is obviously plus 9 cube. So 9 cube is nothing but 729. I hope you have learned the cubes and you are doing it verbally, right? So the number would be 1316. plus 729. So that will be nothing but 5402. So that is 2045 is the next number in the series. So you can see that, the very first approach in this kind of question the people will apply is of multiplication. But you can see this is again a form of difference series, but the difference is in the form of cubes. So that is why there's a huge difference between the first and the last number. That is why in the previous video I told you that this is just an indicator. This is not sure that every time if the first and last number are hugely different, it is not that every time it may be multiplication series. It may be addition or difference as well. That is why I told you it is only an indicative, but it is not something that can be said surely. Okay. Now let's move to the next question, number 9. So the question says 17, 40, 109, 224. So you have to find the next number. So let's check for the difference first. So while going from 17 to 40, there's a addition of 23. Then while going from 40 to 109, there's an addition of 69. Then while going from 109 to 224, there's an addition of 115. Now, at first glance, people will think there's no relation. But then if you know tables till 30, which you should ideally know, tables from 1 to 30. If you know tables from 1 to 30, you'll quickly realize that these all are multiples of 23. So this is 23 into 1. This is 23 into 3. This is 23 into 5. So you can see odd numbers 1, 3, 5. So next number will be the addition of multiple as 7. So 23 into 7, that is nothing but 161. So next number will be plus 161. So 224 plus 161 will give you 385. So that is your answer. So you can see how easy it was. So the difference was in the form of multiples of 23. Let's go to the 10th question. So question says 620, 613, 594, 557. Okay, so now let's check for the difference first, because you can see the numbers are very close. I would not say that close, but yes, they are nearly close. So let's check for the difference thing first. So over here, it's a difference of 7. Then from 613 to 594 is a difference of 19. Then from 594 to 557 is a difference of 37. Now, I cannot see a pattern over here. Like if I look at 7, 19, 37, there's no fixed pattern that I can see. Now, the next thing I will try is multiplication, but I don't think multiplication should work in this because numbers are nearly equal, right? And they themselves are large numbers. So multiplication should, give something huge, should give something big, but then it is not giving. So let me check for Fibonacci, any sort of Fibonacci thing. If you can see, I don't think there's no Fibonacci as well. What's the next thing? I told you do not stop over here. Let's try to check further. But when you check further also in the second step also, you do not get anything useful. So now what should I do? I've tried everything. Now try analyzing these numbers once again. Sometimes the answer is hidden in the first step only, but because we are under too much of pressure, we do not look at that carefully. If you look at 7 can be written as 8 minus 1. If you look at 19 can be written as 27 minus 8. Now, are these numbers something familiar to you? 2 can be written, 8 can be written as 2 cube, 1 can be written as 1 cube. Over here, 27 can be written as 3 cube, 8 can be written as 2 cube. So, kudos, I'm very near to the pattern. 37. Can it be written as 64 minus 9? Not 9. 64 minus 27. Yes, it can be written as, that is 4 cube minus 3 cube. So yes, I got the pattern. Next number should be 5 cube minus 4 cube. So 5 cube is 125 and 4 cube is 64. So next number on the list should be 61. It means, and you know, it is in negative. So this number will also be, next number would be 557 minus 61. 557 minus 61. So when you do that, you get 6 and 9, 496. So that is the answer. So again, this would have taken a good amount of time if you have paused and tried it. Those who have done it in 1 or 2 minutes, give a pat on your back. You are on a good level while your preparation. Others, there's no need to get worried. These all things will come only and only by practice. So please practice more and more. There are plethora of sources. Please practice as much as you can. Okay, let's go to the next question where you have to find the wrong number in the series. So for this kind of series, let us first quickly try the simplest approach of the difference or the addition factor. But as you can see that the series is increasing, so there are chances that, it may be something in the form of difference or subtraction only. So this will be plus 5, this will be plus 9, plus 10, plus 12, plus 14, plus 16. So if you look from here, 10, 12, 14, 16, you can see a pattern. There's an increase of 2 every time whenever the numbers are added. So this is something problematic. This is something problematic. So if I check for the sequence in the reverse order, 16, 14, 12, 10, then this should number, rather than plus 9, it should be plus 8. So let's check. If we do it, plus 8 over here, we get 25. And how do you arrive from 19 to 25? That is from plus 6. So this is also corrected. So this is also not plus 5. This will also be plus 6. But we are asked about the wrong number in the series. So wrong number is 24 and the correct number in its place will be 25. So you can see how easy it was to determine what is the wrong number. It should not take more than 1 minute. Let's come to the next one. So 36, 34, 22, minus 8, minus 64, minus 154, minus 286. So you can see that the numbers are decreasing in the series. They are continuously decreasing in the series. So let us check firstly. So this will be minus 2. This will be minus 12. This is minus 30. This will be minus 56. This will be minus 90. This will be a minus 132. So now, if I look at this, I cannot see any pattern. So what according to you should I try next? I should try multiplication, but then I don't think anything will come out of multiplication because you can see that the sign is also changing, right? Sign is also changing. So, and also last and the first number are not that hugely different in their magnitude. So I don't think anything useful will come out. Let me observe this thing again. So if I try to write 2, can I write 2 as 1 into 2? 12. Can I write it as 3 into 4? 30. Can I write it as 5 into 6? I hope you are realizing the pattern now. 1, 3, 5. So next should be 7 into over here 2, 4, 6. So next should be 8. And yes, it is true. 7 into 8 is 56. Next number would be 9 into 10. That is 90. Then it is 11 into 12. That is 132. So according to this pattern, the next number should be 13 into 14. So that is 182. So next number will be the subtraction of 182. So the number would be nothing but 104. So how do I find the number? Minus 286 minus 182. Please do not make an error in after looking at these negatives. Please do not forget that there is a negative sign in the center. So it becomes minus 286. plus 182. So when you solve this, you get minus 104. So that is the correct answer. Let's move to the next question. Find the wrong number in the series again. So we have to find the wrong number now again. So in this series, there are many familiar numbers. If you look at this series, at the very first look, you can see these all are squares of some known numbers. Like this is 0 square, this is 1 square, this is 3 square, this is 6 square, this is 9 square, this is 225, that is 15 square. 441, you know, is 21 square. But do I see any pattern now? Can I see any pattern between these? Let me try to find the difference now in these things. So, you know, while going from 0 to 1, there's a addition of plus 1. I'm not talking about the square value. I'm just talking about the number 0, then 1 is plus 1, then it is plus 2, then it is plus 3, then it is plus 3 again, then this is plus 6, then this is again plus 6. If you check over here 1 2 3, yes, I can see some pattern till here, but then the pattern becomes very random. If I try to go in the order 1 2 3, so over here it should be plus 4 rather than plus 3. So it means rather than 9 square, this should be 10 square. So if it is 10 square, so next number should be, so this number should be 100. So let me check. If it is 10 square, then you know this also becomes plus 5 and this becomes plus 6. So now you can see the pattern 1, 2, 3, 4, 5 and 6. So the wrong number in the series was 81. In place of 81, it should be 100. So you can see this was very simple, but then do not stop over here. Do not quit over here. Try to check further as well. Okay. Okay, so now let's move to the next question where you can see the very first number is missing. So missing number, then 513, 537, 752, 800, 1311. So you can see over here that, you know, numbers are large enough. So let us try finding for the addition factor first. So while going from 513 to 537, this is plus 24. While going from 537 to 752, this is plus 215. While going from 752 to 800, this is plus 48. While going from 800 to 1311, this is 5 plus 511. So these numbers, if you look at them carefully, these are very close to squares and cubes. These are very close to squares and cubes. Like if you look at 24, this is nothing but 5 square minus 1. If you look at 215, this is nothing but 6 cube minus 1, that is 216 minus 1. If you look at 48, this is nothing but 7 square minus 1. If you look at 511, this is nothing but 8 cube minus 1. So I hope you have recognized the pattern: 5 square, then 6 cube, 7 square, then 8 cube. You know, squares and cube in alternate and numbers are going in the series 5, 6, 7, 8. So the number before this should be nothing but 4 cube, because this is square. So the previous number must be cube minus 1. So you know 4 cube is 64 minus 1, that is 63. So this number, to arrive from this number x to 513, it should be plus 63. So the number is nothing but 450. So this is our answer. So now over here, many of you will stop trying and you'll start moving to other approach like multiplication of Fibonacci or something else. But you know, that is why I told you, please learn squares and cubes by heart, so that when you see numbers like these, you should realize that they are very close. They are actually one less than squares or cubes. So there may be some pattern of this form. Okay. So this should not take more than 1 minute. Let's go to the next question. 6, 4, 5, 11, 45, and then is the unknown number. So let's think of what we can do at the very first thing. Let me try finding the addition or subtraction factor. So this will be -2, this is +1, this is +6, this is +34. So no pattern, because here it is minus then addition and numbers keep on increasing, so I can't find any useful pattern over here. Now what should I do next? Should I try multiplying it with some fraction or something? When you do so many things, then you realize that there's no connection between two numbers. Now it is possible that the individual number may have some pattern which is followed for the further numbers as well. Like if you look at 4, can I write 4 as half into 6 plus 1? I can do it very easily. 4 is nothing but half into 6 plus 1. How do I write 5? Can I write 5 as uh, can I write 5 as 1 into 4 plus 1? Similar way, can I write 11 as 2 into 5 plus 1? So you can see plus 1 plus 1 plus 1. Can I write 45 as 4 into 11 plus 1? So can you see the pattern? Half, 1, 2, 4. Now you will wonder, what is this? Isn't it the double every time? Like half into 2 is 1, then 1 into 2 is 2. 2 into 2 is 4. So the next number should be 8 into 45 plus 1. Very simple. So it takes time to such kind of these patterns to strike to your mind. It takes time, but then again it comes by practice. So 8 into 45 is 360 plus 1. So this number is 361. So it must have taken a pretty long time to identify what is the pattern, but then you should try to cater with such kind of question in not more than 1 to 2 minutes. Okay, let's move to the next question. Says 8, 9, 11, 17, 41, 161, and then there's a blank. So let's try finding the addition factor first. 8 plus 1, then plus 2, then is plus 6, then plus 24, then plus 120. Now, if I look at the very first glance on these numbers, I will find that they do not have a pattern. But now, if you look at this carefully, 1 can be written as simply 1. 2 can be written as 2 into 1. 6 can be written as 3 into 2 into 1. 24 can be written as 4 into 3 into 2 into 1. 120 can be written as 5 into 4 into 3 into 2 into 1. So basically these are factorials. 1 factorial, 2 factorial, 3 factorial, 4 factorial, 5 factorial. So next number will be nothing but 6 factorial. So that will be 120 into 6. See, value of 5 factorial, So value of 6 factorial will be nothing but 120 into 6. So that will be plus 720. So next number will be 161 plus 720. So that will be 881. So that is the correct answer. Also over here, I would suggest please try to learn factorial values, factorial till 20. So this will again be helpful. It will be better if you take out a list and paste it, or you learn it, or you revise it. Try to write it on your own. First find it and then try to write it on your own. But please try to remember it till 20. Okay, this is a kind of rare question, I would say. Generally factorials are rarely asked, but then there can be a pattern like this. Okay, so next is 90, 180. Then there is a blank in between 240, then 48, then 288. So you can see there's, neither increasing nor decreasing. First increasing, increasing, and here it is decreasing and then again increasing. So it may be some sort of fraction multiplication, right? Like while going from 90 to 180, it is into 2. So this number I don't know. Let's leave it. Let's check the pattern for these three numbers now. So to go from 1 to 40 to 48, you have to divide this particular thing by 5. You do 240 divided by 5, you get 48. To go from 48 to 288, you have to multiply by 6. So can you see the pattern, divide by 6, then multiplied by 6. If I follow this pattern of alternate multiplication and division, so over here it should be multiplication by 4, and over here the pattern should be division by 3. So let's check. If you multiply this, so how do you get, if this is x, right? So it means 4x is 240. So this means x is nothing but 60. So this x is 60. Now let us check. Obviously, when you divide 180 by 3, then also you get 60. So you can see alternate multiplication division is there. Multiply by 2, then divide by 3, multiply by 4, then divide by 5, then multiply by 6. So this way the pattern is going. Okay, let's come to the last question for the day. 14, 70, 10, 10, and next. So when you see repeated numbers, the first thing that should come to your mind is, okay, let me try fraction multiplication. So to arrive, 10 to 10, this will be into 1. Now 70 to 10, this can be by divide 7. 14 to 70 can be multiplication by 5. So can I see some sort of pattern over here? Multiply by 5, divide by 7 into 1. No, this is very random. I don't understand anything out of this. Now, what should I try next? In repeated numbers, then we can try Fibonacci, but I don't think there is anything like Fibonacci. But now you have to observe this thing very carefully. If you remember, in the previous video also we did a concept of sum of digits, which we have forgotten till now, right? Like if you try to add 1 and 4, you get 5, and number is also in multiplication 5. If you add 7 and 0 is 7, so divide by 7. If you add 1 and 0 is 1, so multiply by 1. So next number will be nothing but divide by 1 plus 0, that is 1. So next number will also be 10. So if I continue the series till infinity, I'll keep on getting 10, 10, 10, 10, because it's always multiply by 1, divide by 1, multiply by 1, divide by 1. So this is a non-terminating recurring type of series, you can see, right? So this is again a kind of rare series, but yes, obviously it can be asked in the exam to fuse up with your skills. Fine. So these were the questions that we have discussed today. If you have not understood any question, I would recommend please go back to the question, pause it, and try to do it on your own. Also, again and again, I'm repeating, there is a plethora of sources when it comes to number series. Please practice more and more to become familiar with what type of thing can be asked in the exam, or how the examiner can play with your mind. So I hope I must have helped you in some way or the other to recognize basic to advanced patterns. So now it all depends upon how much you practice. So keep practicing. Goodbye until next. So now that you have understood the topic through our videos, I would recommend you to try the practice tests of the topic number series available on our EduRev app. Apart from the tests, we also provide a full fledged course to support you in acing your CAT preparation through 170 plus interactive videos and video lectures, 150 plus comprehensible documents, and 110 plus tests comprising topic wise, section wise, and 20 plus full length mock tests. So keep on doing your rock solid preparation and quickly go and check it out on our app.